I want to tell you a little story of when I was growing up and working on a farm in Canada. One of the farmers I was working for had a gopher problem. They were everywhere, thousands of them. And what he had me do was get a little bit of grain and add some antifreeze to it and mix the two together. And then we'd place this by the gopher holes and they would eat it and they would eventually die. Which brings me to the point, guys. This stuff is extremely toxic and it tastes very sweet. So if you have animals in the house and antifreeze lying around, they will lick it up and they will die. So please be extremely careful if you ever try doing any experiments with antifreeze. So I'm still getting tons of requests in the comments for liquid nitrogen experiments, and as I was scrolling through today, I found this comment from Segasu12 that says, can you freeze antifreeze with liquid nitrogen? That's a really good question. Will antifreeze freeze? And over 800 of you thumbs up this comment, so apparently it's something that you really want to see. So I went and picked up some ethylene glycol so we can put that suggestion to the test. So in preparation for this experiment today, I did a little research on antifreeze, and aside from the fact that it's extremely poisonous, it actually has a really wide operating range. It can get as hot as about 130 degrees Celsius and as cold as minus 37 degrees Celsius. And I'm saying Celsius for all you international viewers out there. Give me a thumbs up if you appreciate that. Will this stuff actually freeze? Will it gum up? Will it turn into kind of a slime or a gel? Or will it turn into like a frozen crystal antifreeze? That's the purpose of this experiment today. Let's find out what antifreeze does in liquid nitrogen. Now for this demonstration, I thought it'd be fun to use this curious looking little dish here. This is called a quaich, and it comes from my good friend George Culver from Scotland. So thank you, George. We'll be putting this to good use today with antifreeze and liquid nitrogen. Let's get started. That is so pretty. It's so beautiful. That, my friends, is what antifreeze looks like. But you would not want to put this in your mouth. It's extremely poisonous. As good as it looks, don't drink it. Because of the way that this is kind of shining, it does make me wonder, what if we took a UV flashlight to it? Wow, that is really cool. That is neat. A little UV light and some antifreeze and you got a homemade glow stick. Who knew? You can control your glow stick. Now this fluid is really curious, and I thought it would actually be a lot thicker, more like glycerin, but if you look at it, it flows kind of like water. But if I put my finger in and just kind of swish it around, it feels more like a watery, sugary syrup. It's very viscous. So let's get into our experiment. Liquid nitrogen, glass dish, here we go. There we go. Look at that bubbling. For as many times as we've used this glass dish, I'm amazed it hasn't cracked by now. It's held up really, really well. This happens every time. Like as the liquid nitrogen has almost cooled the glass down to temperature, it starts rapidly boiling. It gets very violent and usually spills everywhere. Oh yeah, there it goes. Look at all the Skittles. Look how much nitrogen it's taken to cool this dish down. This was filled up more than halfway, and now it's settled down to about a quarter of the glass. So the difference is now the glass is really cold and we could add more nitrogen to it. This nitrogen is homemade, fresh out of the dewar this morning. Perfect. So it looks like our dish is ready. Let's go ahead and lower the quaich. All right, moment of truth, guys. This is pure antifreeze. First test is 100% antifreeze. Let's see how that reacts. I'm kind of like a little bit nervous because this dish is warm compared to that nitrogen. Whoa, my gloves froze, and there goes the... Ha! I kind of knew that was going to happen, but look down here at the bottom. You can actually see the antifreeze is kind of like balling up, bubbling around. That was a total fail, and my shirt is cold. But we still get to see what's happening here. If you look at the antifreeze, it looks like it is turning to some kind of a slightly greenish gel. But is it gel or is it solid? If you look at the slow-mo, you can see it actually froze my fingers. Like the gloves, the tips of my fingers froze solid, and so I had to let it go. Liquid nitrogen repels off the skin faster when you don't have any gloves. Like by wearing gloves, it actually freezes solid and keeps the cold in contact with my skin. So having gloves with liquid nitrogen may be counterproductive. Oh yeah, look at that. It's beautiful. It's very, very pretty, and it was totally an accident. Yep, that's super hard. Look at this stuff down here. I need some way to scoop that out. Oh yeah, look, it froze my fingers solid. It just takes an instant. Oh, that's cold. Look at this chunk in here. Oh yeah, there's a nice healthy chunk of antifreeze right there. That is definitely solid. Whoa! Ah, it's freezing my fingers. It like busted away like breakaway glass, and then it stuck to my fingers and cryogenically froze them like a cryogenic napalm. That is nasty stuff, and you can't get it off very easily because it's very sticky. This stuff will actually crush up into a powder. Check this out. So check this out, guys. We have just created antifreeze snow. Oh look, it's dripping. It's like warming back up and turning into slime. Anti-frozen slime. Oh, you can mush it, you can mold it, you can sculpt it. It's like gel, and it's a little bit translucent, so it kind of looks like the Ninja Turtle ooze I made out of borax in one of my other videos. This stuff is starting to warm up. It's actually turning opaque, which is really interesting. Like, the warmer it gets, the more cloudy it gets. Kind of looks like a lime sorbet. I wonder what it smells like. It has a slightly sweet smell. For the most part, I would say you can't really smell anything. What does it taste like? Just joking. We're not gonna taste it, okay? So we have a little leftover nitrogen in the container here. What would happen if we poured that directly into a cup of antifreeze itself? Let's find out. Oh, cool. Look at the top here. Check this out. So the nitrogen actually floats on the top of the antifreeze, and then it forms like this little crusty layer. That's bizarre. It's like making little islands of ice in there. We'll do a little bit more this time. Yeah, so the nitrogen floats on top of the antifreeze, and then it freezes it, this crusty layer on top. It's almost like a poisonous creme brulee. Let's pour in the rest of it. Almost immediately, the top crusts over with ice, or whatever that is, ethylene glycol. So if you look in here, you can see the antifreeze is pretty much untouched on the bottom, but then it freezes and forms a layer here, and we have nitrogen bubbling on the top. So we have like frozen antifreeze, and as it thaws, it'll form this very viscous, slimy kind of syrup. It's making like a frozen pond of antifreeze. So update, guys, we know antifreeze by itself will freeze completely solid. But according to the container here, if we add 30% water, that'll give us maximum efficiency. So I filled up a container here with a little less than 1/3 of a cup of water. And so if we fill it the rest of the way with antifreeze, we should theoretically have a 70-30 mix. And we can see how that reacts. A solution of antifreeze in water has a very wide temperature range, and that's very important because most automobile engines are water cooled. If you just use water by itself, there's a couple problems you might run into. If it gets too cold, the water can freeze and turn into ice and clog up your radiator. And if it gets too hot, it can flash into steam and cause extreme damage to the engine itself. But by adding antifreeze to the coolant, you can now widen the temperature range because it has a much lower freezing point and raises the boiling point dramatically at the same time. So in the interest of conserving my precious homemade liquid nitrogen, I'm going to pour it into the quake here and let that cool down. And then we'll take this antifreeze water solution and just slowly pour it in so we can see the reaction close up. Okay, so here we go. Our quake has cooled down. We got little bits of my glove floating around in there. Let's go ahead and take our antifreeze water solution and just drip it down inside. Here we go. Oh, sweet. It's like bubbling on the top and then sinks to the bottom. Will it freeze? That is the question. Now, I'm no expert, but I can clearly see the answer is yes. Look at that. It's like made a bubble. It's almost hollow on the inside. It's made a bubble of water and antifreeze. Whoops. And it's very, very fragile, apparently. I'm just gonna drip this stuff in slowly and see if that makes any difference. Now that is kind of cool. For a second, it seems the antifreeze just kind of bubbles and floats on the top. Come check this out. That is neat. That looks pretty freaking cool. Oh, do you see that bubble just squirt out? While you're looking at that, I'm gonna put some UV light on it. Ooh, look at the way that lights up. Whoa. You know, after this stuff is frozen solid, it kind of looks like crystals of kryptonite. Yeah, that stuff is rock hard. Adding water is still no match for liquid nitrogen. So will liquid nitrogen freeze antifreeze? I think the answer is apparent. Yes, it will. And we had a lot of fun doing it today. We also made antifreeze snow, I didn't even know you could do that, and found that UV light will make this stuff light up like a glow stick. All super cool experiments, and all because you asked for them. And big thanks to Sadducee12 for suggesting this experiment today, and all 814 of you that thumbs up that comment. Keep an eye on your YouTube inbox, Sadducee, I'm sending you 25 bucks. And thanks to all you guys for hanging out with me today. I'll be looking for you in the next video. Talk to you then. I think this thing is actually stuck to my workbench. I can't get it up.